Welcome back on. Sorry, Johnny can start you. I have an issue.
Welcome back to the our series of events and webinars from the Data Innovation Lab. Today we'll talk about the 5 V's of machine learning. We have a special guest with us. It's Alessandro Festa from SUSE. Hello, Alessandro.
Hi there.
And today, as I was mentioning, we'll see the 5 V's, meaning what we want to do with what we do and what we want to do with ML, why we want to do it and we do it, when a company needs us, why a company should hire a dedicated team for machine learning projects, and what value that team can bring to the ML lifecycle.
Yep. Sorry, I'm back. Before starting with the session, please write a message tell us if the audio and the stream is okay. In meantime, Alessandro, could you introduce yourself, please?
Sure. Thank you very much. So I'm Alessandro Festa Alex. I'm the Senior Product Manager for AI initiatives at SUSE. SUSE, for those that don't know who is as a company, is one of the longest Linux kernel maintainer worldwide. We literally been founded a few years after that Linux Torvalds released the kernel, and since then we keep maintaining the kernel. So it's more than 29 years that we are on the market. I'm responsible for every AI initiatives, especially with targeting MLOps and AI ops. So AI as infrastructure more than AI as application.
Gianni, we are a co-worker in Delta 3, particularly in the Innovation Lab. Please, could you describe what is our main activity?
Yeah, for sure. Our daily job is R&D at 360 degrees around emerging technologies, new technologies, and especially on AI and machine learning stuff applied to multimedia data, but not only that, and everything related to how to bring ideas from inception, from prototypes to production, helping our teams to bring ML models up and running at scale.
So for our jobs, we wear the different hats, covering from data engineering to ML engineering, and also wearing the hat of MLOps. Alessandro, I think that it could be better to introduce the life cycle of a machine learning project because, as we know, is a little bit different from a classical development.
Yeah, no, absolutely. So, well, let's take a look at the slides. You're absolutely right. Machine learning lifecycle is slightly different from the typical product lifecycle, if you want. As a product manager, I know very well that the product lifecycle has a specific steps they need to follow. You basically have a vision, you basically identify the idea, then basically you evaluate the idea, you go through the development, and from the development you go through the launch phase, and after the launch phase you basically monitoring the product as it goes through its life until to the point where you retire them. But when it comes actually to develop an AI project, we need to face another kind of life cycle, that we call machine learning life cycle. So let's start from that. And I ask you actually, Gianni especially, since he's actually is highly involved in the operational part of this life cycle, to jump any time actually to share his thoughts and experience on that. So like any project, we start from scoping the project. So scoping the project basically means we need to identify what we are trying to achieve what use case we try to solve, what kind of AI capability we want to inject in a future product. Practical examples can be like we want to build a digital assistant, an NLP kind of solutions that can help the company when it comes to customer support. So reply to customer questions in a human kind way, and be smart enough to understanding what the human actually is typing, or even talk using voice. Or maybe we want to release in the healthcare scenarios, we want to create an app that identify disease into the X-ray scans. So actually we can help the radiologists to identify those more quickly and consequently saving more lives. So scope is really important and is a first step. And of course, we need a team. We need a team that need understanding all the various flavors that are within the scopes. This will lead us to the experimentation phase. Now, between the scope and experimentation phase means we identify what we want to achieve. We identify what kind of data we probably should have, how the data will be presented there, how we need to build, or if we rely on existing data. What kind of approach from a mathematical perspective, what kind of model we think, what kind of algorithm we're going to think. So there are many moving parts there that we will try to explain that require multiple personas, multiple kind of professionals there. From the experimentation phase, we move to the training phase. That means we identify the algorithm, the right model, we develop more or less the model, we identify a data set, whether it is the test, the validation, the production data set, and then we go up to the training phase. The training phase typically is more the computational part of it, where we actually we try to teach our model to recognize the real-time data. And that actually leads us to the last part. That is what we call the prediction phase. Prediction phase means we take the model, we pass the model to the inference engine, and inference engines actually try to match real-time data against the model. If the model actually learns it correctly, it will actually provide the right prediction or the right responses. So our NLP actually will answer in a human-readable way. But of course, this is not a one-shot process. It's an iterative process. Why? Well, because over time, there could be various kinds of drift. Maybe during the training phase, our model is not accurate enough, has not the right performance. We see that there's a drift when we move from the test data set to the validation data set. So we need to come back to experimentation phase and rework some parts of our process. Maybe the drift is under prediction. The data change over time. It's real-time data. So the data change over time, our model actually losing accuracy, losing performance, and so on. So we need to come back to retrain, or even further, the model is not anymore valid and we need to go back to the experimentation phase. This is typical, even if this is really a high-level version of machine learning science, but this is really typical of the things. That means also there's a lot of effort from various professionals actually to understand when it's time to retrain the model, when it's time to reevaluate the model itself. And for example, I'm asking Gianni here if he shared the same experience, if he see the same complexity in the project that he actually worked out so far.
I agree on almost everything you explained. Mainly, if we want to understand better the differences between an ML lifecycle and the standard software lifecycle, we can say that the first part, from the scope to the train, is the development phase of a project, while the last part is the production phase. So when we want to deploy something in production, it means that we already did all the development up to the training phase, and there we have some develop some pipelines that can publish something in either in a staging environment or in production environment, and then it makes it available to third parties. These third parties mean that we don't need to limit ourselves to endpoints and websites, for example. Third parties can be apps, can be embedded devices, can be a mix of something on premises, something in the cloud. So there are different kind of issues that usually in the software normal standard lifecycle doesn't happen.
Yeah.
We usually have a straightforward line from the scope to the production, and then we don't have the loop. Instead, in ML, it's fundamental to understand this. We don't know, especially when business needs come to us and say, we would like to obtain this. First, sometimes obtain what is something that even they don't know. So we need to sit with them, understand with them what they want to achieve. So scoping is one of the first phase. But scoping also requires experiment. Sometimes we don't know if what they want to achieve with our help can be done. So the initial part of the experimentation phase is also a prototype. Maybe it's something that can be something, a few days of experimentation, a week of experimentation, say, okay, it makes sense what you want to achieve, so let's experiment. And then there is also all the life cycle that you mentioned.
Yeah, and absolutely. And you actually you mentioned a really specific word that actually it's super important. That is, this is mainly a DevOps kind of process, but it's super important because you introduce a different kind of ops in this picture. Actually, it's introducing a lot of new professionals in these pictures. First of all, we mentioned before MLOps. So for those basically that are watching us and eventually that they don't have a full understanding of what MLOps are, let me give you my own definition of MLOps versus, for example, another buzzword these days that is IOps. MLOps is a specialized operation DevOps that is specialized on this machine learning lifecycle. It means he has an understanding of the machine learning lifecycle, of the tools that are going to be used there, and the various steps that you were mentioning before. Whether AIOps is this concept where you use AI within a tool, an existing tools, to operate your infrastructure. Within monitoring, you're using a tool that actually can spot failures before time. So AIOps is someone that doesn't know AI. MLOps is someone that works this life cycle and need to collaborate with the other profession that we need to figure out who they are, what they do, where, and what kind of value they can bring to this process. So let me move on to what we do. I said, well, here's the new professionals that will work on that life cycle. And I created these personas just to explain more or less at a really high level the team. The team could be more complex than that, can be other kind of professional. But for sure, we have data scientists, we have data engineers, and we need to define the difference between data scientists and data engineers. We already say we probably have an MLOps operator, but also we can have a machine learning engineers. And again, we need to figure out the difference between a machine learning engineer and a machine learning operator. Those are the minimal personas that basically can be combined in an AI team. And why they are important? Because each of them can iterate in that process in various pieces. I gave you my own definition. Then I will ask Gianni actually again to compare his own view on this. In the scoping, of course, we would expect that everyone actually collaborate together because, as Gianni was saying, sometimes we even don't know what we're looking for. We barely know the use case. We barely know, we have a glimpse of an idea of what we want to achieve, but we need to figure out how to approach the problem. The scope part could be really long. It needs to be highly detailed because we need to figure out where we start. And often the starting point is the experimentation phase. It's literally a prototype. It's like a POC. In this phase, mainly who work there is the data engineers and the data scientists. The data engineer is super important. It's the first one that probably jump in the project because there's no way actually to have a successful AI project if we don't have enough data quality. And data quality requires a lot of time to be built. First, because as Gianni was saying, because sometimes we don't even know what we're looking for. Second, because we need to figure out what kind of data we look, what kind of features within the data set we're going to build we need, how the data can bring value, how much is the quality is high. That means that there's no, between brackets, white noise within the data that actually will degrade the model later. And in this phase, the collaboration between the data engineers and data scientists are really high because they need to understand together how to implement the data later to the mathematical model. Between the experimentation phase and the training phase, because actually when we say train could be many times, could be against the various level of data and level of models that we need to figure out which one actually apply better to our use case. The machine learning engineers and the machine learning operators start to kick in. For two reasons. One, because we need tools. We need tools to track what we do, track the model, the training of the models. We need tools to actually implement the models, but also we need to optimize over time these models. And again, this interaction comes and go on even when we go to the production phase, when we go to the prediction. And in there, again, the data engineer, the machine learning engineer, they keep working with the machine operator because they are responsible to understand if they're eventually data drift or content drift, or we need a further optimization. And we need to actually to monitor if everything is being running correctly. And again, I'm pause here for a second and asking Gianni actually to give his point of view on this step.
I agree on everything, but I would add something in the prediction phase. You said that we have the ML engineer and the ML operators there, but also here we have the standard software engineer.
Yes.
Because usually AI models, ML models are just a little part of
Yes.
a bigger project. So we need to understand and talk to them in that phase how the model will be used. So we can expose it as a website, a REST API, or we just expose some function as a library, and then an application can load it and run it. Or we can expose it as a embedded device I was mentioning before. So we need to understand how to re-engineer it and to make it working in limited resource constraint. So low memory, real-time requirements, and so on. So here the software engineer, together with the ML engineer, work at very fast pace, because of course everything must be fast to understand. If something fails as soon as possible, we can reiterate and go back at probably at experiment level to see if something can be changed or need to be addressed.
And correct me if I'm wrong, one of the challenges you face in that is that the standard software developer or the standard DevOps has no idea what all this stuff is about. He has no idea about what a model is. He has no idea. All he probably knows is the way you expose the model to him to pick up and inject in the application. But that's actually provide a further level of complexity, because you have no time to explain what you are doing or what you are delivering, but nonetheless, you have to integrate it with an existing application or the new application.
I believe that also about the management, the PM should know the life cycle of a machine learning project.
Yes.
Because we are talking about the communication between two very specialized actors in this life cycle. But of course, also the PM, from my point of view, must understand the problem, the issues, and should be the clue from all the actors.
Absolutely. You're absolutely right. Actually, there are two kinds of PMs involved: the project manager and the product manager in that, and they are both super important. As you say, especially for product management, not because this is what I'm doing, but actually because one of the key points in AI project is exactly what you were saying. That is, there's a lot of expectation, because almost everyone, and I got a couple of slides later that actually say that why we do it. That is about, everyone thinks that AI is easy or is some sort of magical. Oh, we do AI, and of course we're going to solve any problem. But I often use Richard Feynman, the physicist, actually to explain how things are different. And I'm always use this quote from him. Well, one day David Gonstein, that is another theoretical physicist, actually asked Feynman about, hey, can you explain me why spin 1/2 particles obey Fermi-Dirac statistics? And Feynman said, well, you know what? I'm going to prepare a freshman lecture on it because I know it so well that I can explain it to a freshman, to someone that is new to the college. But after a couple of days, he came back and said, no, I couldn't do it. I couldn't do it because I couldn't reduce the explanation to freshman level. It's not that easy to explain. That means that I don't really understand it. And that's actually that I like this quote because if you look at the last sentence, it goes back to another sentence of another great physicist that is physics that is Einstein. And Einstein was saying, if you are not able to explain in simple word a concept, means you don't understand it. Now, AI is all about this. That was what Gianni was saying at the beginning. If you have no clear idea what you're looking for, you cannot solve it. That means also that if you have no clear idea about the entire project, you cannot explain to your stakeholders. So you need to really manage the expectation because, as we said before, it's a different life cycle, has a different timelines, especially as timelessness says that in the early stages of the project, and this is where the project manager for AI and the product manager for AI need to collaborate, require a lot of time. And this time can be even longer, and you need to manage the expectation because that is the key part of the project. Serving the model to the inference and consequently to the mobile devices, to the edge devices as a REST API is the easy part in the end because the model has been already trained, the precision, accuracy, and so on are there, everything's fine. But explain to your stakeholders that you require 6 months to prepare the data set that will actually be the base to train a model. That is something that you need to be real careful how to manage. And that's super important. And again, I'm asking you guys, because you are highly involved in the operational side of things, actually, if you agree with this sentence and with the whole concept, or if you have a different opinion.
I agree 100%, and I would also to talk about the timelines. You said that a lot of time should be spent in the first phase of life cycles. Have you some numbers?
Yes, so I can tell you something that it comes out. I got 2 numbers. The first number is 80% of an AI project is just rely on data. Means if you don't have your data right, you're gonna fail. And to give an explanation of this, I'm mentioning Algorithmia State of Machine Learning for Enterprise report. Algorithmia is one of the players in the AI space, and he basically produces this report every year. The state of machine learning in enterprise tells you that the average time to make production with a model is between 80 days up to 90 days, 90. Now, to be fair to the report and do some more conservative calculation, let's say that actually the average sits between 30 and 40 days. We spend a month just to reach our production with a model. And when we reach out to production a model after a month that the company spent money, we did not get any money out of it, then we start the iterative process. And we're speaking about a number that compare super mature companies. If we look at less mature companies, that means that we are more toward the 90 days, 3 months, just to have a model that starting from an existing data set goes to production. Now, just think about how much time we need at that point just to prepare the right data set. That is why we got 6 months, 1 year just to prepare the data set. Now, if you look at those numbers, and again, this is the Algorithmia State of Machine Learning Enterprise report that you can Google it and find it easily. Explain the complexity and explain exactly what Feynman says here. If you don't understand it, you cannot make it. And if you cannot make it, you're going to fail. But the problem is that you will fail spending a lot of money waiting for something that will never be there. And in fact, when a company need an AI team, now say the AI team seems more like a movie, but that's what it is actually. That's super cool about that, by the way, because what you're doing, I'm working on the AI team. Now you just need to figure out who of the item are you. So I'm using these as a topics, but I will ask Gianni actually, and you can also to basically to jump in and give you your question there. But my question typically are, first of all, whatever has been thrown to me, my first reaction is, can we solve it in traditional way? Are we sure this is really AI, or can we just use standard analytics, standard statistics to do that? Because often you find out that you don't really need AI in the project. And if not, why not? Or why yes? Why we really need AI? Because that leads you to the last question for me, that is what the stakeholders expect from this. Are they still trapped in the AI magical capabilities kind of idea, or they have a full understanding of what means bring AI into their lives? And again, practical example, I was mentioning the customer support NLP. It's fine. Everyone these days speak about, oh, why we don't have a Facebook digital assistant that actually can help out our customers to, for example, book a ticket for a flight. You go on Facebook, you look for KLM, you look for Delta, you look for almost everyone, and you probably have such a digital assistant. And I think that everyone that tried one of those, at least in the early days, you remember the frustration of the process. Standard response, not really human feeling, sometimes trapped in infinite loops. And in the end, you think about, okay, maybe I can keep solving these in a traditional way with a more standard approach that says these are the fixed responses, and once you reach out the fixed responses limit, you will basically derive it to a human kind. So that is exactly the use case where we say, can I solve it in traditional way? Yes. Why? Well, because my AI capabilities are not that in advance that I can solve it in a different way. 2 years later, can I solve it in a traditional way? Yes, but now I got GPT-3 that helped me out to reach out a better NLP kind of bot, and so on and so on and so on. Is improving, retry, remodel, retrain, and then go ahead. But again, I'm stopping here. I'm waiting for you if you have any comment on this as well.
Yeah, I can add that starting from the last statement there, AI magic capabilities. Yeah, people usually think that AI is that a magic black box. That okay, we have some data, throw it at an AI model, and we'll find out that there are tables, there are numbers, there are predictions, there are objects, and so on. Okay, it is possible. You have a lot of examples around us that make that working, but what's behind that? So if you think that you see currently a model that can detect objects and 3D shapes from a single image or a video, okay, but to obtain that, meaning we the community, the research community, spent the last 6-7 years to obtain that. And to understand how it works, and also we come back to the idea of the scoping of the project. If we need exactly what somebody else has done, has shared a model, that can we take it as is and use it, okay, that's fantastic. We need maybe 2 to 3 months from going to ideas, prototyping, and production. But if we just need a little variation of the model, we don't want to detect, for instance, a shape of an object, but we also want to understand its internals or its specific details. That's where the AI magic, people think that there is, but then you talk to data scientists and say, okay, let's talk from now to 6 months. Let's see if we have enough data, the right data set, if we need to label a data set, where we get the data set. Because you mentioned GPT-3. GPT-3 is a huge model, and there are similar ones for image recognition, video understanding, text transcription, and so on. But to obtain that, it costs a lot. You have a lot of examples, annotated examples, where to store them, how to practically versioning it, where you get the resources for GPUs, CPUs, memory, and so on. Just for example, training a GPT-3, Clement, I don't remember, it's about $4 million. It was something.
Yeah, and by the way, GPT-3 requires something like 15 days just to freeze the model before actually go to the next checkpoint.
I believe that the biggest issue, the biggest problem is that people, want to utilize this magic box, but believe that it's simple to feed the magic box with a data set. You need to balance the data set, label the data set, and also you need to save the snapshots during the training phase, and are all costs and time that people doesn't consider. And of course, the scope of the project should consider the cost in time and in money to achieve the goal. Okay, I want a super precise model, or it's sufficient public model?
Absolutely. And I give you even a better representation of this that actually Jenny was mentioning, for example, the use case where I'm trying to recognize a shape through an image or a video. Facebook just released a new project because what they basically they were just thinking about was the majority of image recognition data sets are working from the standpoint not of the viewer, but of a third person. When you look at the videos, it's always a video recorded from a third person. And you train your model to recognize the shape from that angle. So they literally released this new project where they're building this big public data set that is basically video recorded in the wild from an in-person point of view. And this reason is that this way they can train model to work with VR's systems. Because it seems like easy, but actually if you think about that, there's this slightly difference that Jenny was mentioning between teach a model to see through the eyes of a third person, so with a different angle, versus teach a model that need to recognize the shape from an in-person point of view. Because if I'm using a VR set, then actually the model could potentially not work. And if we expect to have VR's, Google's, pretty soon as a standard way of living, that is super important. And that actually is where, for example, a machine learning engineer and a data engineer especially, in this case, need to figure out that they have to use a different data set, if the data set is public or not, if it need to be customized, how can they be customized. And even the data scientist need to figure out again how the model behave against a different kind of data set. Because eventually we figure out that our existing model doesn't recognize anymore the box as a shape because it simply is viewed from a different angle and it has no idea how to recognize it. And that's actually super important. That actually goes back to the expectation. You as a product manager, especially, you need to explain how from time to time, and there's no way to avoid it, we will have to come back to retrain the model, to reevaluate the model, eventually even reevaluate the data we have, take different direction and decision. And so we will spend more times in doing that than actually making to the production. And this is super important. Like it's super important to explain that any AI software that you're releasing over time will degrade. Over time will be not precise anymore. And over time we will need to be reevaluated. So this is an ongoing effort. It's not just a static process. And so that actually goes to the why a company should hire an AI team. And again, I'm using this as a reference, as a topic. This is a sort of joke to explain what the AI team does. Where is the green tab? Do you see it? I give you an hint. Just look at the right of the green tab voice. Here's the green tab. Do we have all the tabs? As a human, I will spend too much time there. As a computer, probably I can figure out pretty easily. That's a stupid example, but how do you solve that? How do you know that those tabs are the right tabs that you're looking for? And maybe you need to recognize specific shapes, and maybe you need to figure out how to do that. Now, unfortunately, I did not have the Lego picture, because probably if you are not aware, you can Google it. There's a great app for mobile devices that basically you point your mobile to a bunch of Legos, and it will tell you what you can build on top after a few seconds. This is using pretty pretty simple AI there. That's why you need an AI team. But who is the AI team? Because we keep saying that, and I should come back to the personas, but actually, here's my perfect AI team. Data analysts and data engineers. Those are the first two people that I'd like to have in a team, because they can figure out what we need to use as a data, what we have as a data. Data analyst knows the data we have, data engineer knows how to build data set out of it. Then I want to have a data engineers and a machine learning engineers. One is needed because you can figure out the approach to build a project, to build the right models with that kind of data, and can work out to explain what kind of data you expect to solve the use case. And the machine learning engineer, because he knows what are the technologies that actually can use within that approach. And finally, the MLOps. And I keep see many companies that specialize data scientists to let them become MLOps. And I think that is a terrible mistake. And it's a terrible mistake because an MLOps need to be someone with a huge expertise on the infrastructure side of things. So it should be made, it would be preferred to be a DevOps that specializes himself as MLOps. Otherwise, you will have someone that has a highly understanding of the machine learning, but really poor understanding of infrastructure. It will go through try and fail. And actually it's not that it's not acceptable, but it's just a waste of time. And again, I'm posing here to ask Gianni, who's your perfect AI team?
I would add something to what you mentioned. The perfect AI team, in addition to the data analyst, also has some of domain expert in the specific field that you want to apply ML or AI. Yeah. It can be the data analyst, of course, but he has to be specific in the specific domain. Yeah. And also, from the other side, you were mentioning that MLOps as a very expert on the infra side. But let's say that he should be expert in different parts. He needs to talk to the data engineers, to the software engineers, to the data scientist, and to the ML engineer. So he has to be sometimes the hat of all of these persons and understand what they need. So probably, yeah, you were saying that probably it's better to a DevOps to become an MLOps. But let's say also a software engineer can become an MLOps, because there is a lot of instrumentation tooling that needs to be written, or pipelines, traditional ways, DevOps pipelines, so CI/CD pipelines that have specific needs for ML. But if you don't understand the traditional software engineering parts, how to componentize things, how to automate things, how to do scripting, how to store secrets, where to store secrets, where to store resources, etc., a data scientist doesn't understand this.
Yes, no, absolutely.
He can, of course, achieve the knowledge, but probably will be, as you've been saying, it's a lot of lost time, and maybe it's not something that the data scientist wants to do. He loves the data. He doesn't want to understand and build infrastructure. He just cares that he can open his Jupyter notebook, run on his machine, on her machine, and then once the requirements are satisfied, okay, here's the Jupyter notebook. Please have it run it in a production environment. Yeah. That's what they want to do.
In fact, one of the biggest problem is that the data scientist's code isn't ready to scale up on the infrastructure. Yes. And almost all the time is within a Jupyter notebook. So the key role of the ML engineer is to extract the code from the notebook, re-generate it in order to scale up with the help of an MLOps.
Yes, and in fact that is absolutely right. And I think that I want to really clarify one point just to be sure that whoever is watching us, it doesn't misunderstanding this. The MLOps is not. It seems like the jack of trade is like a generalist that can do everything, and is absolutely like this, but is a specialist in doing all those things. So it's not someone that has a barely understanding of all those things. It's someone that has a good or even deep understanding of all those things. So it's someone that actually specializing themselves. That's why MLOps is a new trend and a new approach in the market. It's like DevOps 10 years ago, if you want. If you're a front-end engineer, it doesn't mean you're a back-end engineer. Those are highly specialized. But if you're in the DevOps, you need to understand in front-end and back-end at the same times. The MLOps does exactly that. You need to understand what the data scientist is saying and what the data science requirement, like you were mentioning. If I'm on the Jupyter notebook, as a data scientist, I'm super happy. I can do my own job. But if you want to make that Jupyter notebook in production, you need to actually abstract and change it and recode everything, and so on and so on. So that's absolutely super important. And that actually brings us to the last V. What value we bring as AI team to the machine learning lifecycle? And actually, I think that the value, we just explained the value. The value is that as a team, we can solve complex problems, achieving a better level of production from our perspective, providing this capability actually to go there and provide the AI stance. But at the same time, also we can provide value because we can cut off the time to go to production. We optimize the way the company is using his own money and actually bring that. The problem there is just that all these things seems really complex. And again, I ask you, Gianni, but actually I'm pretty sure that whenever you approach a machine learning project, that means tens of tools that need to be used. Every time someone bring on a new tool that need to be integrated, need to be used, you need to learn, understanding. And like you were saying, like you have to scale, you have to distribute those models to various devices and so on. And that really brings a lot of complexity. And so I basically just introduced a really new project that I'm working on with my team as a community open source project. That is with the idea of, can we make it easier, the life of the AI team, at least for the MLOps perspective. And so we spoke before about the idea of the complexity of a machine learning lifecycle. So this project called FuseML is an AI orchestrator. So his idea is to combine all the steps we described before in a way that can be automated, automatically integrated within the various tools that you're using in a project, like in a kitchen, in a food recipe. Think about a food recipe where you can literally combine the ingredients, and you will end up with your own recipe that you can use over time and reuse over time. And if you slightly have to change it, like one tool versus the other, then you will be able to do that. That is FuseML. And I'm basically using just this slide to complete our conversation around machine learning cycle, just to explain how FuseML works. You see the machine learning life cycle. Let's say that the experimentation phase is just an area of code exchange, or if you want, a team collaboration, Git, for example. Let's say that we call it concept, but the concept is just a Git repo where you can do versioning, you can branching, you can commit, you can do PR, so you can collaborate, whether you are data scientists, data engineers, machine learning engineers, etc. So you basically work out the prototype. And once the prototype is more or less ready, you can easily pass it to the next steps, like, for example, a training, just to try out the model, using an agnostic workflow. That's your recipe. The workflow is just a logical description of various tools that actually can be used together to produce the outcome that you expect. Let's say, for example, you like to use MLflow within Kubernetes, but using Kubeflow pipelines and Tekton as a backend engine to train the model. Or let's say you want to use Katib as a hyper performance optimization, again with MLflow. And maybe you want to extend the workflow at some point up to the prediction, where you want to use things like NVIDIA Triton Inference Service, or KF Serving. Now, in the wild, doesn't exist any integration between MLflow and KF Serving, for example. Or you want to use Seldon as a way to go there. This workflow creates a dynamic assignment. This is what we call an assigned workflow. This workflow basically creates a dynamic link between the experimentation phase and the train and prediction phase, so that every time you do a change of the experimentation phase, it will trigger one or more workflow on one or more instance. So actually you can have the full automation there. That actually can even be injected in another CI, the standard DevOps CI, where actually you can end up on the smart app. This way, we basically avoid all the friction that were existing during these steps, allow you to reuse your existing tools, so you don't have to reinvent the wheel or relearn the tools, and then make it. And as I say, this is an open source project. It's already being released, and I'll leave this slide at the end just to give you the pointers to the presentation. GitHub.com FuseML, where you can actually you can see this example of a machine learning end-to-end. We also have a YouTube channel, but also the docs where you can find the tutorials and go there. And with that, I'm basically stop here. I don't know if there's any question from the audience or if you have any other comment, feedbacks on these talks, you, Gianni or Clemente.
I think that this orchestrator is a good way to speed up the experimentation phase and also the fast production releases. Yeah. I think that every team that are working in this area of ML production should take a look at this project. I did it. It's very interesting. And so go ahead, click on the link below in the comments and give a star, a like on GitHub. Yeah. Of course, this can help the project to go ahead. Absolutely, because as I said, this is a completely open source project, so everyone is welcome to contribute. But of course, like every project out there, need to be known by the others. So give us a star. So it's a beautiful way actually to help us to spread the word and actually grow the community around it. And about the license, okay, open source isn't always free to use. Mm-hmm. In this case, is absolutely free to use. You can absolutely be free to use. So go ahead, you can fork it, you can use it, you can download it, you can do whatever you like. And of course, the best idea you have, whatever idea is, open an issue and we'll be more than happy to consider the idea and actually to make it happen within FuseML. Great. Gianni, we can mention other tools to speed up the experimentation phase or the production release?
There are two tools that I would like to mention. One is not a tool, it's just a framework. That if you want to speed up your experimentation phase and start from high quality models and high quality state-of-the-art models and data set that you can start and experiment on your idea, is FastAI. It's a framework above PyTorch, which gives you a Keras-like interface to PyTorch, where you can easily train and test models in computer vision, NLP, and tabular data with a few lines of code, and obtaining a very high quality baseline, let's say. Then, of course, you need experimentation. Bring your own data set, do the changes. Everything is open source. You can have access to the models and do your own verticalization. The other one is Key3AI. Key3AI is an interesting tool that helps you start from your own workstation, your own machine, to develop models, experiment model, starting from simple. So you want to test your pipelines. I don't know, if you use Kubeflow pipelines, you can deploy Kubeflow on your own machine and test and debug it there. But once you are satisfied with the results, it's just a matter of changing configuration, and you can be up and running on any Kubernetes cloud provider, for instance. You can deploy it in Google, in Azure, or wherever you want, or have a mixture of the two. Meaning you have your laptop or you have your on-prem data center with your own machine, with the Kubernetes cluster, you can use it as a target for deploy, and then scale it in the cloud and having an hybrid approach.
John, I believe that Alessandro could tell us more about this project. We are lucky today.
Yeah, because that is my pet project along with Gabriele Santomaggio, that is the co-inventor of K2AI. Actually, I give you an hint. K2AI is going to be let's call it the next version with a lot of new features. Just to give you a couple of hints. First of all, we're going to support VMware Tanzu Community Edition. We are already supporting Amazon AKS Anywhere, plus, of course, Rancher K2S, as we used to that. And also, we are going to introduce support to many other tools, not just related to Qflow, but also MLflow, Rflow, and many other AI tools. And last but not least, what we are going to be able to is take in sync multiple clusters of devices. Means you will be able to define a configuration and then replicate the configuration of multiple clusters and maintain in sync that configuration with your master cluster. So whatever you change there, it will be replicated automatically to the other clusters.
So it's similar to a GitOps for
yes.
a machine learning environment.
Yes, exactly. The whole idea is give a GitOps approach for machine learning, but for the CI/CD kind of approaches. So whenever you have to rapidly test, create a cluster, install the tools, push the pipeline, and then destroy based on the results, that's K2AI perfect scenario. I expect actually to release it by the end of this month. So actually, I would be more than happy actually to showcase the next K2AI and let people try out.
We saw a preview from Alessandro and can't wait to see it online. Any timeline for this project?
Yes, absolutely. I think that if, let's say, more or less should be end of this month. So I think around the 31st, let's say by Halloween, I should release K2AI.
Okay.
Actually, so.
A terrific project.
Yeah, a terrific project. Yeah, in all senses.
Great. Do you know other tools, Alessandro, that could be useful for orchestration and operations?
Yes. Well, we mentioned Qflow. Qflow is probably the most known open source project in the AI space. It's always a good starting point because it allows you to try out different steps, different tools within the same platforms. And Qflow uses as a backend engine for the pipelines, Tekton and Argo. Argo is definitely another platform that actually can speed up, especially a combination of Argo workflows with Argo CD. Those are tools, but one tool actually in the cloud provider, for example, could be the Azure pipeline, Azure Machine Learning Pipeline. That's absolutely great. Azure is absolutely a great starting point as well. And well, just to mention the other two big vendors there, Amazon SageMaker and Google Vertex. Google Vertex is, if you want, the extension of Qflow. And finally, this is the last tool that came to my mind. Well, we spoke about complex scenarios, but sometimes you don't really need to have those complex scenarios, but you just need to figure out more simple scenarios. In that case, AutoML can really help out. So Google AutoML could be really a great starting point. The limitation of AutoML, at least from my point of view, is that the name says, is AutoML. You don't really have the capability to go to the extreme customization, etc. But it can give you a rapid understanding of what you can achieve with an idea.
Great. And about the K2AI, you talked about many times you don't require to set up a cluster in a big and expensive infrastructure. With this tool, I can set up on my machine, for example, all the necessary tools to run a pipeline.
Yes.
Let me give you an example. A student can download a project from GitHub. I can simulate a cluster on a little laptop,
Yes. So K3I allow you to don't think about what you want to achieve. That means I'm on a laptop. I don't have kube control. I don't have Helm. I have no idea what Kubernetes is. I have no idea. I don't want to learn how to install things like Kubeflow, MLflow, Argo, and etc. Katiba, as we mentioned, those that we mentioned before. All I have to do is just download the K3I binary, run it, K3I app, then basically just, well, if I'm an advanced user, pass a configuration file. Otherwise, I just have to say K3I cluster deploy K3S or deploy kind, and then K3I plugin deploy Kubeflow pipeline, and that's it. Few minutes later.
So I don't need to learn a lot of stuff that maybe I don't require for my job, but I can focus directly. An example is so complex to set up a cluster with K3I.
No, it's a matter of just running one single command. And actually, well, I definitely can show you if you want the easiest installation.
Could be great.
Yeah, just give me a sec. I will have to actually to just start my machine, my working machine, and then be good there. Just give me a second. I will stop the screen share and just start there. In the meantime, because this is a live thing.
I believe that after this live, Alessandro will kill us.
No,
because
actually,
we are asking about things that he haven't already on machine.
Actually, what you don't know is actually that while I'm speaking to you, my dog literally is jumping on my lap all the time. So this is really challenging. The challenging part is not about showing K3I. The challenging part is actually go there and actually explain what K3I did. What K3I does while your dog actually try to eat your legs. Okay,
just to add something while we wait for the spin up. We did some experiment a few months ago on Kubeflow, and you mentioning Azure ML. We've been able to combine both worlds, meaning that we will be able to build on our own machine the pipelines, test them, and then deploy them up and running in Azure ML. We test locally using Kubeflow, and with some workarounds, but we can discuss next time. It can be easily adopted and ported to Azure ML, for instance.
Yeah. Okay.
Not bad. Can open a lot of scenarios. Johnny, I believe that one of the biggest issues for an ML engineer is to test on own machine the real infrastructure. Of course, it isn't the same to run some things on machine. Could be perfect to run a model on the real environment, production environment, but it's very expensive. And in many times, there are really available the resources. For example, for many models, you require a specific accelerator, like last version of NVIDIA Tesla. And also, if you want to book them on Azure, Google, AWS, they are not always available in all the regions. And the price, the cost for a single test could be very, very unbelievable. So the opportunity to simulate an environment with one line in the command line, I believe it's amazing. Now, so, if the dog...
there you go. I'm just sharing. I was just looking for. Okay, let me show you quickly a couple of things about K3I. So this is my development machine, but just to explain there, just to show you that I basically have a standard machine. So there's nothing there basically. Let me show you what I can do. Now, I'm not using directly the binary. I'm using my development machine, so that's why go run dot. But actually, let's start with the standard. So as I said before, K3I basically has a really few commands: down, up, cluster, plugin. So let's say that, for example, I want to know which plugins I can eventually install on my machine, and I will pick up just a couple of things. Oh, sorry. Plugin. So K2I basically check the plugins available on the public plugins repository and tell me those are the plugins available. Right now, you only see a couple of because this is my development machine. So I have constraints there because I can do even that. For example, I can use Khatib or KFP. But even further, I can say with the same logic, plugin list.all, I can say, how about the clusters? What kind of cluster I can actually install? Oh, sorry, again, my typo. And then you say, well, here's the actual cluster that are ready. AKS, K3S, Kind, Tanzu, you pick up whatever you like. I said I want to install a cluster like Kind. So I can say K3I, go run dot for me, cluster, what, deploy, what, the type, what kind of cluster you want to like. We say that I got Kind. Give me a name of a cluster, name my Kind cluster, and a hit. And you can start, oops, and there you go, an error. Oh, that's super cool. That's the beauty of the things. Maybe I changed something slightly on my things. Let's see if it goes there or I have an error. Well, I'm sorry. That's the beauty of the lives. Well, basically, what it does at that point, it will basically that it deploy the cluster. So because I have time actually to check that. Let me just show you a video of this that actually can help out. That I will just
no problem.
I'm sorry
He's
about
gonna
that.
prepare the demo, so it's okay.
Yeah. But no, it's just a second. Okay, there you go. And this is what I was mentioning before. That was exactly what I was saying before. You see, actually, I'm doing exactly the same stuff that I was mentioning a few seconds ago. So the list basically allow you to list the plugins, as we explained, but also you can basically list the cluster, as I explained before. And as you will see, that actually is what I was describing before, is that then at that point, I can basically install the cluster directly. So for example, I can say, do I have any cluster deployed right now? I have to give a list in this case. I always do typos even when I record the thing. And it says, well, no, you don't have any cluster deployed on your machine right now. Or even on a remote machine. And cluster list deploy says, these are all the clusters that I as a K2I knows. So I'm doing a K2I cluster deploy in a second. Give a type, for example, K2S in this case, give a name, whatever I like. I can even don't have to give a name, and K2I will generate a name for me, like my K2S cluster, and off you go. It will take the upstream version of K2S, latest version of K2S, download for me, install for me. If you're on WSL, it will take care of the fact that you don't have systemd. And as you can see, 30 seconds, and the cluster is being deployed. I see my cluster there, and I can actually operate with my cluster. Now, I'm not showing you anything fancy, terminal, kube control, blah, 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 etc. I'm doing everything from K2I. If I want to remove the cluster, and I can even do whatever I like, there you go. You click, and we follow exactly the upstream process to do so. So that's the beauty of K2I. From there, if I do exactly the same stuff that is like K2I plugin deploy -- name Khatib, queue for pipeline, Argo, MLOps, it will basically just ask me where -- target my K3X cluster, and we'll be there. And that's it. That's all you need to actually run. Now, just to explain why you saw an error before, it's pretty easy to explain. It's because what I was trying to achieve this morning is to even give more optimization to the K2I. The idea is not just to clone whenever I need a clone repository in memory in order to run customize as a tool, but also cache those repositories so they can stay there for a day minimum, so you don't have to download it again, and you can actually use in-memory capability there. And that's basically why now that failure, because basically it was probably pointing to a non-existing file system right now. That's why, because as Gabriele Santamaggio, the other co-inventor, always says, Alex, you're a great product manager, but please stay away from the code.
Okay, compliments for this project. I remember you that you can try simply clicking on the link below in the comments. Utilize it, give feedback to Alessandro and Gabriele, and maybe contribute to this amazing project.
Yes.
I love not only the capability of these tools, but also the CLI. The user interface for me is so intuitive, easy to utilize. I don't need to remember every command. It's so easy to set up a cluster, etc., etc. Anyway, thank you for your time, guys. I hope to see you again very soon.
Yep.
And stay tuned on this channel. If you have any questions, leave a comment below, and we'll try to answer as soon as possible. Ciao.
Ciao.
Bye-bye.
Bye.